Hello, today we're going to continue building on what we did in our last lesson with graphing exponential functions. But if you look at the equations like you see here today, it's not just a parent function, and it's not just, so my pen going there, it's not just something that looks like y equals something to the x. We now have things being added or subtracted up in the exponent, added or subtracted at the end of the equation, or spoiler alert, seeing numbers in both spots. That is perfectly fine, nothing to worry about there. I will get you through that process. We're going to start things the same way with these. We are still going to start by making our table of values with our favorite x values, -2, -1, 0, 1, and 2. And then I will tell you here in just a moment how we change things a little bit. So what I have here on the right-hand side of the screen is the different things we can see going on in equations. So you do see a number in front here. We are not going to see that in today's lesson. We're going to save that for next time. So don't worry about numbers in front here, which means we aren't going to worry about this part right here either. We'll talk about that in the next lesson. When we see a number up in the exponent being added or subtracted here, it's going to move your graph left or right. And it's backwards of what you think. If it's a minus, it's going to move your graph to the right. If it's a plus, it's going to move your graph to the left. So kind of a counterintuitive there. If we have a number being added or subtracted at the end of the equation, it's going to move your graph up or down. If it's a minus, it's going to move your graph down. If it's a plus, it's going to move your graph up. And so we'll come back to what this looks like here when we actually do some graphing. So like I said, when you see these today, you're going to start the same way as you did before. Make your table of values for your parent function. Using -2, -1, 0, 1, and 2. What I mean by the parent function is just the whatever to the x part. So when I make my table of values, it's going to be for y equals 2 to the x for number 1. So I'm going to go in the middle of my table. I'm going to start with 0. 2 to the 0, anything to the 0 power is 1. 2 to the 1 is just 2. 2 squared is 4. And then to do my other values, we talked about this a little bit in the last lesson, some reciprocals. Since 2 to the 1 is 2, 2 to the -1 is 1/2. Since 2 squared is 4, 2 to the -2 is 1/4. And if I didn't have this plus 2 up in the exponent, this would be the graph I'd be looking for. However, I do have a plus 2 up in the exponent. So that plus 2 here, since it's a plus 2, is going to move our graph to the left too. So what it's going to do is, instead of this point going to be at -2, 1/4, it's going to be 2 points to the left of that point, which would be -4, 1/4. And I'm going to go down my table the same way. Instead of this point being at -1, 1/2, I'm moving to the left 2. It's going to be at -3, 1/2. So what I'm doing here is I'm subtracting 2 from each of my x coordinates since I'm moving to the left 2. 0, 1 becomes -2, 1. 1, 2 becomes -1, 2. And 2, 4 becomes 0, 4. So now I'm going to graph these points here and find the graph that goes through them. And if you would like, you can start with the bottom of the table with our points that are not fractions. So I'm looking for my graph to go through 0, 4. Doesn't look like letter A quite does that. Letter B does not do that either. Letter C does not go through 0, 4, but letter D does. Let's see if letter D goes through all the other points as well. -1, 2, pretty good. -2, 1, -3, 1/2, and -4, 1/4. So letter D is the winning graph here because it goes through all of those orange points there. Let's try another one. So for number 2, let's start by making my table of values. Same ones as always, nothing crazy there. -2, -1, 0, 1, and 2. But this time I'm plugging into the parent function 3 to the x. Like I did before, I'm going to start with the middle of my table and then do the negatives. 3 to the 0, or anything to the 0, is 1. 3 to the 1 is 3. 3 squared is 9. And then reciprocals, 3 to the -1 is going to be 1/3. 3 to the -2 is going to be 1/9. Now, I'm not going to graph those. I have to deal with what this -2 at the end of the equation means. This minus 2 here, since it's at the end of the equation, is going to move my graph down 2. And so then I'm going to take each of my coordinates and move it down 2. I'm going to start with at the bottom of the graph and work backwards. Instead of being at 2, 9, I'm going to move that point graph down 2, so it's going to be at 2, 7. So when I move down 2, I subtract 2 from the y coordinate. 1, 3 turns into 1, 1. 0, 1 becomes 0, negative 1. And then with my fractions here, 1/3 minus 2 is negative 1 2/3, or negative 1.6 repeating. 1/9 minus 2 is the same as 0.11 minus 2. And so this point turns into negative 2, negative 1.8 repeating. So you're welcome to write these as fractions or decimals, whatever works for you. So then let's go ahead and graph the red points. So once again, we'll start with ones that aren't fractions or decimals. I'm going to start with 2, 9. I'm looking for my graph to go through the point 2, 7. So 2, 7, looks like letter A does go through that. Let's check the other points. 1, 1, 0, negative 1, and it looks like the decimal points are in the right spot too. So A is the correct graph. Let's see why the other graphs don't work. B does not go through 2, 7, so that doesn't work. C definitely does not go through 2, 7. D does not go through 2, 7, and so by default it is letter A. So then 3 and 4, same idea, but just notice that now we have numbers both in the exponent and at the end of the equation. So as always, start with your table of values. Making our table values for just the parent function. So for this one, it's just 1/3 to the x. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. 1/3 squared is 1/9. And then reciprocals for the negatives. Reciprocal of 1/3 is 3. Reciprocal of 1/9 is 9. And then we're going to deal with both of these moves at the same time. Plus 2 up in the exponent is going to be left 2. Plus 2 at the end of the equation is up 2. So if I'm moving to the left 2, I'm taking 2 away from the x coordinate, so it becomes negative 4. If I'm moving up 2, I'm adding 2 to the y coordinate, so it becomes 11. Let's do the same process with the other points. Left 2 turns negative 1 into negative 3. Up 2 turns 3 into 5. Left 2, 0 goes to negative 2. Up 2, 1 goes to 3. Negative 1 goes into negative 1. 1/3 plus 2 would be 2.3 repeating, or 2 1/3. 2, when I move to the left, 2 is 0. 1/9 when it moves up 2 is going to be 2.1 repeating, or 2 1/9. So now we're going to graph these maroon colored points, and I'm going to start with the ones that are not fractions or decimals. So I'm going to start with the point negative 4, 11. So negative 4, 11 would be here, which letter A does not go through. Letter B does definitely not go through. Letter C does not go through. It looks like letter D is going to be our winner. Let's check it out. Negative 4, 11, bingo. Now let's check the other points. Negative 3, 5. Negative 2, 3. And then the other things are going to be a little bit above 2. And so that all checks out. D is the correct graph here. Let's do one more to make sure we've really got this down. So once again, start with our table of values. Always the same 5x coordinates, negative 2, negative 1, 0, 1, and 2. Our parent function this time is y equals 4 to the x. So we'll start in the middle of my table. 4 to the 0 is 1. 4 to the 1 is 4. 4 to the 2, or 4 squared, is 16. Reciprocals then here are going to be 1/4 and 1/16. And if you like those better as decimals, 1/4 is 0.25. 1/16 is a very small decimal, 0.0625. If that helps you, you can do them in decimal form too. All right, so then now let's look at what we've got going on here. This +1 here is going to be left 1. This -1 here is going to be down 1. So I'm going to move each point left 1 and down 1. So -2, when I move to left 1, becomes -3. And then if I move this, if I do 0.0625 and I round it, I'm going to get -0.9 here. So then -1, if I move it to left 1, it's going to be -2. And if I do 0.25 minus 1, I get -0.75. The rest of them are going to be a little easier since we don't involve fractions or decimals. 0 to the left 1 is -1. 1 minus 1 is 0. 1 minus 1 is 0. 4 minus 1 is 3. 2 minus 1 is 1. 16 minus 1 is 15. So then we're looking for the graph to go through these orange points. I'm going to start with the ones that are not, I'm going to start north backwards. I'm going to start with 115. Letter A does not go through 115, which will be right about here. Letter B, looking pretty promising. Here's 115. Let's check the other points. 1, 4. Sorry, 0, 3. 0, 3. I'm backwards there. 0, 3, -1, 0. And then the fractional ones work out as well. So letter B is going to be our correct graph here. Checking the other graphs, letter C does not go through 115 at all, and letter D does not go through 115 at all. So same process as we've done before. Make your table of values, find the graph that goes through all of those values, and you can use this cheat sheet here to help you remember left, right, and up, down. That is it for this lesson. In the next lesson, we will talk about what happens when there's that A multiplier in front. It's just one more little piece of the puzzle, but nothing we can't handle. Have a wonderful day.